Hi everybody. I'm going to show you a quick example on solving relative motion projectile problems. Let's say that you have a tank here. And it's driving along at a certain speed, and it fires a projectile, and that projectile is going to go and land somewhere down the line. Now when you break this vector, this velocity, into its x and y components, the y component is really not affected by this tank driving left to right. The y component is still the same. You can use the y component to find the time that this thing is in the air. However, the x component of the velocity that the tank is driving at does matter. So let's just make up some numbers. Let's say that your y value is 10 meters per second and your x value was 4 meters per second. If you solve for the time it takes for this shell to land, and let's say the time in the air is 2 seconds, and you wanted to know how far away does this shell land, what's the range, we would do delta x equals velocity in the x direction times the time it's in the air. The only thing is, the velocity in the x direction is not just the 4 meters per second, it would be also the velocity the tank is driving with. So let's say the velocity of the tank is 1 meter per second. You'd have to add that to the 4 to get 5 meters per second in the x direction. And then multiply by the 2 seconds that this thing is in the air, giving you a delta x of 10 meters. Now obviously this is a tank firing a shell, it's not going to give you a 10 meter range, it's going to be a lot larger than that. I'm just giving you some ballparking, easy numbers to look at.